Welcome back to another lecture, and today we're going to be looking at each of the different particles. Now, when it comes on to radioactivity, we have equations that we normally use to symbolize how the decay normally happens. Now, radioactive equations are balanced in terms of the mass number and atomic numbers, right? And it's normally called a nuclear equation. Now, when a nuclear equation is written, the total mass number on the reactant side must be equal to the total mass number on the product side. So it's just like the balancing of equations in chemistry, but we use the mass and atomic numbers as the means of balancing it. Now we'll be looking at alpha production. When alpha is produced during radioactivity, the mass number of the daughter product will be 4 less than the parent nuclei, and the atomic number will be 2 less than the parent nuclei. And thus, that's why we call it the helium molecule. When it comes on to beta production, when beta is produced during radioactivity, the mass number of the daughter product will be the same as the parent nucleus, but its atomic number will be greater by 1. And when it comes on to gamma production, when gamma is produced, there's no change in the atomic or the mass number of the daughter products that are produced. Now we're going to look on the decay of tungsten. Now, as we mentioned earlier, the sides must be balanced. So we have 184 on this side, we need 184 on that side. 74, 74. Now, in this case, we're going to have to find 4 less than this number. Now, 4 less than 184 is 180. And 2 less than 74 will be 72. Now, all you need to do is to look on your periodic table and find out which element is 72 and has the atomic number of 72. Now, based on that, the element has a symbol of HF. And that would be how you'd work a decay for alpha. Now, let's try this one for yourself. What will be the atomic number for the new element produced? Alright, so let's work it together. We're going to have 234 Pu 94. It's undergoing alpha, so we know it's going to release a helium. We need to minus 4 from the 234. That's going to give us 230. Minus 2 from the 94 with a plus sign, and that's going to give us 92. Now let me ask, which element has an atomic number of 92? And that would be uranium. And that's how you'd symbolize the alpha decay and the equation. And it depends on the type, so you can go ahead and practice some in our work session.